Sometimes people will come up to me and say, hey, it must be really fun to make computer games. And honestly, it really is. But it's also very difficult. So it's kind of like putting together a jigsaw puzzle with all square pieces and no picture to help you put them together. So there's a lot of tutorials online, books, and various other sources that will try to step you through the process to use some random tool that they prefer. But there's no actual learning that happens in that process. So I've decided to go ahead and start a series of videos and step you through all the different processes and hopefully not gloss over all the important pieces that actually make making a game possible. And it's not so much about the code, it's more about the actual process.
Ow! I'm studying! I promise!
Today's video tries to focus on the actual essential pieces that have to be in a video game. So a game engine, a controller system, kind of system for drawing things to a screen. There's also some other parts that are not required but fairly common that I'll identify as well. One of the more well-known components of a computer game is the game engine itself. So you might have heard of names like Unreal Engine or CryEngine in the past. There's also ones like Unity and Monogame or RPG Maker. They're all various game engines. They all do effectively the same thing. They're just better at one thing versus another. They all have good points. They also have negative aspects. So picking one is kind of whatever your needs are and then learning how they function. But overall, they all do the same thing. They need to display something to the screen. They have some kind of user input, so a way to display items from the game, using audio, music, and making sure that the game is functioning the way it's supposed to along the way. They're very generic, and you can push any kind of major game into it, and it should function the same way for all of them. One of the more common buzzwords that are thrown around in the gaming community is things like Vulkan and DirectX 12. But most people don't really fully understand what that means. Those are just APIs, so a portion of things that can be in a game engine. Vulkan is just a graphic processing unit, and DirectX has that along with audio and keyboard support. So they're just a portion of something. It's kind of an advanced programming piece where it integrates components into another location that's easy to access. So one of the major problems with game engines and APIs is that over time, the code changes from one version to the next. Or if you're changing from one to another, then you have to go back to your game code and change a lot of different items in order to correct for it. The alternate method is to put in something called a wrapper. So the wrapper acts as the interface between the game engine API and the game code itself. The game code will end up working with all the functions that you put into a wrapper, so all of the options for rendering, all of the sound and other support, and then the wrapper itself ends up working with the API and the game engine in order to interface for it. Yeah, it's a little slower, but when it comes down to game development, the most important part is not making the most performance always. Sometimes it's actually just a matter of saving time in the long run. This is some basic code I use for a game engine called Monogame. I use it mostly for 2D rendering, and I have some basic objects I've created along the way. In the first one, like a render object, it's a generic texture that I can reference and give extra features like giving it a draw call, setting colors, and so on and so forth. Other items would be like a manager for doing audio, various user inputs, and eventually even drawing to the screen. When I have the ability to draw to a screen, in most game engines it requires something called a draw call, which are really inefficient, and I'll get to that in a second. But having a manager for that, I have the ability to just add generic objects into some kind of list system as layers, because 2D graphics like layers, and I can even determine if that object is even inside of the actual visual area, so don't have to draw things that aren't actually in the visual area itself. Then it also gives me extra features like the ability to create new textures, modify them along the way during runtime. But the main one that you have to worry about is this draw call. So in this one, I just say, hey, as a function, I want to draw things to a screen. I don't care as a game programmer what that entails. I just say, hey, draw every frame. Inside of the wrapper, I can basically handle whatever type of game engine I want to work with, and it's transparent to the outside of how it actually functions. So in monogame, there's this begin and end call. It's incredibly inefficient, so reducing that down is very important, which is true for a lot of game engines. And then I just work my way through each stack and layer position and tell it to draw to the screen as if it would be anywhere else in the game itself. Doing it this way, I do it only one draw call. I draw a bunch of things to the screen, I finish it off, the game engine automatically throws it onto the screen for me. But as a game designer, I don't have to worry about this process. It's already done. The wrapper handled it for me. I change the engine. It doesn't matter anymore. Another interesting one is resources. Pulling things from hard drives and putting them in RAM is problematic depending on which game engine you work with. This one was quite difficult to work with for a lot of different reasons. But having some kind of resource manager as opposed to the default one that's built in the engine gives you the flexibility in order to support all of the different recall positions, associations that you might need based off of how you want to work with the game. And as your game engine changes, it doesn't really matter because the function calls themselves don't change. Programming is basically just a loop and a whole bunch of condition statements along the way inside that loop. And games are really not that much different. You have two basic types that you can work with. The first one that's probably most familiar is something I call an application loop. It's where the program pauses and then waits for something to occur, like a button push, and then reacts to it in some way. So like in a text editor, you might have a button, you hit save. In a game like tic-tac-toe, you wait for somebody to click on a square, and then it reacts, decides where the computer is going to play, and then it makes that display change. Another option is kind of something that's more familiar for games. You have a flight simulator, for example. You have planes flying around all the time, whether the user's interacting with their plane or not. Or in an RPG, you might have creatures running around all over the place while they're waiting for the user to actually interact with it in some way. So it's just a loop where everything happens all the time, but it searches each time it has an opportunity to see if the user has interacted in some way so they can make that adjustment to everything else that's in the game. And I call that more of a game loop. Some games can be somewhere in between, like chess, for example. You can have it be a user makes a move and then the AI decides where the next piece is supposed to go to. Or it can be where it's always thinking about the next possible moves and all the different options, and then when the player makes a move, it looks at the long list of options that it's already found and then determines the best result and plays that option. So it can be either or in some situations. The game loop is pretty much just an update and a draw cycle of some type. It might be at 60 frames per second, be a good example. I'll go over this in the next section. But pretty much an update is responsible for doing any of the game logic that you would need. So user controls, moving things around the screen, and so on and so forth. The draw call is more responsible for the actual drawing of items to the screen itself. That's kind of where the main separation is. This can be done in a lot of different ways and in different asynchronous or synchronous cycles, but that's really a game design issue. The main point is that game engine will set up some kind of cycle system for these so that they come up at a regular interval of time. With draw and update loops, two different issues kind of come into play. One of the issues that comes up is that people expect that it's updating and drawing at exactly the same time. But often that causes a lot of problems and isn't exactly possible. So everything's going to be out of sync in some way. So you might have 4 update calls in the same time amount that you would have for a draw. But if people want more FPS out of their visual experience, then you might actually have 1 or 2 updates per visual field. So There's got to be a balance there somewhere. The other problem is that you can't draw the items that are physically moving around the environment. It's something that has to be out of time sequence there. So you might have a bunch of updates, and then after the update, you might have to draw. But the problem there is that if you want to draw at the same overall frame rates, now you have shortened the amount of time you're allowed for each update and also for the actual draw itself. So if you want to have a lot of things on the screen, now you no longer have enough time to draw everything to the screen. So you have other option is draw everything out at the same time while you're updating afterward, and now again everything's out of sequence. Either you have stutters from the physics being reduced for a certain amount of time, or you have to draw less to the screen, and these are issues that every game designer has to work through. I'll do a whole other video on these type of frame issues as well, because all this is physics, all your AI has to happen all in this short amount of time. The other issue is that you have an inverse proportion of time versus how many frame rates everybody wants. Everybody wants 240 frames per second. That means as a programmer, I now no longer have enough time to process everything I need to process every frame. I can't draw 4K images at photo quality at 120 frames per second. It's just not possible right now. So some kind of change has to take in place where you give people what they want, but within reasonable limits for the programmer itself. Something that's common for like microwaves and TVs is something called a state machine. You have, and this state is capable of doing these particular tasks, and it can move from that state to another state to complete other tasks, like a menu system. Games work the same way. So you might have a state for the splash screen at the very beginning that moves into a menu that moves into the game itself. Some engines might even call this a scene, but it's a state machine. And you're going to have some kind of state machine diagram, which kind of assists the programmers to understand how progress from one state to another throughout the program itself. So where can you exit the game from? How can you get from one menu to another? How are you going to get from a menu to whatever game aspect is needed? So this state machine is something you're going to work with, and each one of these states is a separate object, sometimes stored in memory at all at the same time. So you can bounce from one to a state to another with no real wait time because it's already been generated in the background. That gives that aspect of really to the user where everything feels instantaneous, even though it took 20 seconds in the background to generate in the first place. Once you learn the basic components that go into a game, then you have to worry about the actual hardware it's going to run on. So like a CPU, the GPU, and the RAM. They're all important components. Most people forget about the hard drive though, because all the files are stored there for long term. But it's too slow to run the actual game off of, so you have to have RAM and cache in order to support it. You have to get it there too. The large files, like for a model or an image, need to be moved from a hard drive, which might take a couple seconds, into RAM and make a copy of it there. Then from that copy, you can make further copies that are distributed to the game itself. So you have a base copy, and then you have all the different versions of it for like a ship. An image is plastered all over every wall. Those can be modified, and you only copy off of the RAM version so that it's fast overall. Those individual items that are copied from it are then deleted as soon as they're not needed, but you maintain that base copy so you can keep pulling more and more of it from it. The problem with this is that RAM runs out. It's not an infinite supply, so you have to kind of balance how many objects are allowed, how many copies are allowed. Are there tricks that you can use in order to minimize the number of copies in the most efficient way for actual storage size? And then sometimes you have to leave things on the hard drive and pull them as needed. It depends on what your uses are, when you pull them, and so on and so forth. So remember, RAM is actually very important, and where you store things, where you copy them to and from, this in mind is part of the design aspect of a game. Other hardware that's pretty much required is actually the controllers. So a mouse and a keyboard would be a control device, a joystick or a gamepad, or various other things like visual. Those are all different controllers that you have to manage. There's lots of different ways to support them. In a normal application, like in Windows, you have an event. So a click occurs, you ask the operating system if something had happened and then it's handled, or in some situations you need a little bit more response time because sometimes those events are lost. So you might have active polling of a keyboard and mouse to see if what's the state right now. Is the button pushed and held down right now? Is it been released since the last frame or the last 10 frames? Was there a double click? It becomes very complicated over time, but you might want to have a manager for that, like I showed you in the wrapper. Those are all different ways of handling it. One's more active, one's not. One can be more beneficial. And I've seen situations where a mouse click was completely missed, was held down for a while, it was let go, but it still registered as being held down because the event was lost. So active polling can be useful. But it's also more difficult and annoying. So these aspects are something to work with. The game engine will kind of handle that for you in many ways. If it doesn't, then you might have to do it manually. Pretty much every game, even now, has one thing in common: 2D graphics. It seems odd that a 3D game would have 2D graphics, but it's in everything that I can think of, because you have to have some kind of HUD system or a menu. Those are all 2D graphics that are layered on top of each other. It might even be layered on top of a 3D graphic. So working with 2D graphics is very important. Get used to working with them, how to change the coloration, how to arrange them on the screen so that it's the same for everybody. And depending on how the resolution works, then you have to move them around automatically. So working with 2D graphics is absolutely required. With all the major components already out of the way for required items in a game, there's still a few optional ones that are pretty common. For example, a physics engine is pretty much in every game now. You're going to have some kind of 3D world, you're going to have collisions, so therefore you need a physics engine. You're going to move things from one place to another, you're going to be dealing with death by vector math. Sorry, it's just the way it is. There's a lot of helpers out there, a lot of great resources of how to work with them, but it's going to be death by vector math. Other ones are going to be like an AI. So the AI is going to have a lot of processing to do. It can be very simple, it can be very complex. Each one has its benefits. Sometimes the simplest option is going to be the most realistic to the user, or good enough in order to fool the user into thinking it's kind of intelligent behavior. Sometimes even just randomization works out that way. The last piece is going to be 3D. It's not required. A lot of 2D games exist out there, but a lot of things are going 3D now, even when it's not necessary. So working with 3D adds a lot of complication to the system. If you wanted to work with 3D math, if something in 2D took 2 functions to work out, it's probably going to take 3 times that in the 3D world. It's just the way it works out. So it's a lot more complication. Those are the basic components of a video game. And future videos will dig deep into those particular topics and try to explain how they work and the various nuances of each item. If you have any comments, just go ahead and let me know.
Ow! I'm studying! I promise!
Around, so this will still occur while they're waiting for the user to click the trigger on their button, their mouse, or on their button. Use this tool, do these steps, and there's no actual learning in the process. So I decided to make a series of videos. Wow, I was doing so well. I was doing so well. Meow. Meow. Yes, Annie, I am going to tell him that. All those important details are very important. Yes, I know you're disappointed in me. I messed it up so many times. So many times.